more on the meets exceeds type level for target 13 on graphing polynomials. You do have to think about the end behavior and the leading coefficient. So this one has a negative leading coefficient and fourth degree. So since it's even degree, it's going to do the same thing at both ends. And since the leading coefficient is negative, it's going to go down at both ends. And I suspect since it's fourth degree, it might have a couple loop-de-loops like that, where it could potentially have 4 x-intercepts. So then I'm just going to make a table, pick some easy values like 0. So if I plug 0 in for the x, I'd get negative 0 to the 4th power plus 1. If I plug 1 in there, I'm going to get 1 to the 4th power, which is 1, but then it's negative, so it's negative 1, and 0. And when I raise negative 1 to the 4th power, I'm still going to get the same thing as when I raise positive 1. So then I could go to 2 and do 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's going to be negative 16 plus 1, which is negative 15. And negative 2 is going to be the same thing. And if I were to keep going, if this gets bigger and bigger or approaches positive infinity, this number is just going to keep getting smaller and smaller, approaching negative infinity. So as x approaches infinity, the function approaches negative infinity, which means on the right it goes down. And likewise, same thing here. On the left, it's going to approach negative infinity. So I just plot those points, 0, 1. That's a special point. That's a y-intercept. Negative 1, 0, and positive 1, 0. Those are special points. Those are x-intercepts, or also called roots, or zeros of the function. And this one's the y-intercept. So then after those points, it's just going to go really steeply down. And I don't know if there's any other loops or turning points in there. So there's your function. Remember, you can also verify that function using a table in your calculator. So now if I go to this next one, I'm going to approach this the same way. It is a positive leading coefficient of degree 5, so odd degree. So it's going to do opposite things at both ends. It's going to increase at the right end and fall on the left end. And in the middle, it might have some loops. So I'm going to make a table again, pick some easy values like 0. So if I put 0 in there, I'd get 3. If I put 1 in there, it'd be 2 minus 1 plus 3, which is 4. And I could keep doing that. I could use synthetic substitution. If I'm using synthetic substitution, I'm taking the coefficients. 2 is the x to the 5th coefficient. 0 is the x to the 4th. There's no x to the 4th. Negative 1 is the x cubed. 0 is x squared. 0 is x. And then the 3 is the constant. And let's just try putting 2 in there. So f of 2, I bring down the leading coefficient. I multiply it to get 4. I add it to 0. I multiply the 4 by the 2. I add it to negative 1. I multiply the 7 by 2. I add it to the 0. 14 times 2. Add that. 28 times 2 is 56. Plus 3 is 59. So when you put 2 in, you get 59 out. Now again, you could verify these using a calculator. So I have that equation put right in here. It's in y1. So as I'm looking through this table, I can see some of these values in y1. There's the point 259, 1403. So I got another point, negative 12. And then at negative 2, it's at negative 53. And I can see it's just going to go to negative infinity here. That's the left end. And this end's going to positive infinity. So I basically need to make sure my graph hits these 3 points. Negative 1, 2, 0, 3, which is the y-intercept, and 1, 4, which is the x-intercept. And then after this, it's going to negative infinity, so I have to have a really straight down curve there. And up here, it should go straight up. And notice it should never cross to the right of this line, because really the next point would be the point 259. So it's a really steep graph at that point. And in the middle, it might go up and down like that. But actually, we'll talk a little more about the turning points. I think this one's just going to kind of be a gradual wave in the middle there like that. The nice part about these graphing calculators and a function like Desmos on a computer is you can see that as well. I've got 2 on here, but so it does look like it's just kind of a wave in there. Any questions on target 13? Yeah?
On the test, do you have to write out the table?
Your points have to hit the precise table points.
Okay.
So if your graph is accurate, it's okay. But it might ask also, like, what is the y-intercept, or what are the x-intercepts or roots? Okay, so